Hello everyone, I am Krystal Torres and will be today's narrator for the episode. Our usual narrator is taking a break from all the episodes with SpongeBob. For today's episode, let's make a knock-off lava lamp and break glow sticks. But with a twist, we must explain the chemistry behind these experiments, so let's get started. Beginning with Barnacle Boy, who is going to be making a lava lamp. For this experiment, you will need a bottle with no rims, water, oil, food coloring, and aqua seltzer. First, fill up your bottle halfway with water and add in your food coloring. Look at how the food coloring diffuses in the water. Why does it diffuse so slowly? Heat is the reason. Heat is a form of energy that results from the motions of atoms and molecules. Moving particles have kinetic energy. They are constantly colliding with each other. Imagine two large groups of people. One is wearing blue and the other is wearing red. Say the blue group is moving rapidly at a constant speed. So when the red group intertwines with the blue, they mix fast. Taking what was shared, apply the same concept to the water we used. The food coloring diffuses slowly, therefore implying the water was cold. These molecules were moving at a slow pace, not colliding with the food coloring and allowing for a rapid mix. Here is a demonstration of how molecules look depending on the heat of water. In the heated water, there is a lot of space. In the room temperature water, there is a limited amount of space. And in the chilled water, there is no space. The more space there is, the more diffusion. Let's take a quick look at our second experiment. This experiment will be performed by Mermaid Man. For this experiment, you will need glow sticks. Let's now look at what Mermaid Man is doing. While you may think there's nothing much going on, a lot starts to happen when the glow sticks are cracked. Before cracking them, the glow sticks are filled with potential energy. Potential energy is the energy that is stored in an object, or in simpler words, it is the energy that has the potential to change into another energy. When the glow sticks cracks, it begins to glow so you can see change that is happening. That is an example of potential energy transforming into kinetic energy. Kinetic energy is the energy an object has when a force or motion is applied. Take a look at this image. If you see the balloon, it is filled with air, and that air is energy that has not been transformed into kinetic energy. But when the air is released, kinetic energy forms. Same thing happens with the glow sticks. Back to the lava lamp. Next, you will need to fill the other half of the bottle with oil. Do you see how the oil and the water are not mixing? What a strange reaction. How is this even possible? Density. Density is how well the particles are packed together in a unit of volume of material. In order to know the density of a substance, you will need to know the formula, which is mass divided by volume. If a substance has a density of 2 and is combined with a second substance that has a density of 3, the second substance will sink. This is because the second substance has a greater density than the first substance. Water has a density of 1 and oil has a density of less than 1. Therefore, you can see the oil sitting on top of the water. Here's an example of substances when they have a higher density compared to substances with a lower density. Higher densities are so tightly packed together, whereas lower densities are loose and have much more space. Back to the glow sticks. The two substances that glow sticks contain are fluorescent dyes and hydrogen peroxide. Hydrogen peroxide is an acid, although pretty weak. It has a pH level of approximately 3.6, proving that it is an acid since substances that have a pH level of less than 7 are considered acids. Take a look at this pH scale. It demonstrates how you know when substances are acids based on their pH. It also shows everyday uses on this scale as well, such as bleach, egg, coffee, tomatoes, and so forth. Now, let's add the Alka-Seltzer to the lava lamp so far. What a whack reaction. But did you see the way those bubbles formed when the Alka-Seltzer was added? Those bubbles are gas, and that gas is a tell that a chemical reaction is happening. A chemical reaction involves the formation of new materials. Let's go back to the glow sticks one more time for the last time. Glow sticks are made with a glass separating the fluorescent dyes and the hydrogen peroxide. When you crack the glow sticks, this results in the glass also cracking, allowing for the two substances to mix. While you may think this is a physical change, it is not. The reason it's not is because a completely new substance is being created. The molecules of these two substances are being combined together. This same thing was happening to the lava lamp. Chemical energy transforms to light energy. Light energy is a form of kinetic energy that makes light visible to the human eye, and light energy is what allows us to see the glow sticks. Here's an example of physical changes versus chemical. With physical changes, there are changes in shape, size, or group. With chemical changes, the substances itself transforms into something different. That is a wrap, and that is all I have to say. The usual narrator will be back on the next episode of SpongeBob. Thank God.